So we are going to be looking at 6C of the Unit 3 and 4 methods textbook. This is a revision exercise from Unit 1 and 2. So be mindful of that. It's something that you should already understand. So we are going to be learning to understand further symmetry properties and the Pythagorean identity. So we've got complementary relationships here. So we need to be understanding that relationship here, and that is that here, this creates a triangle. And if we're thinking about our cosine here is our A area, then that is going to transfer over to using it from here, which is our theta, and this will be the same distance, our A. So that means this then turns into sine, and it's pi over 2, take away that theta. So that's what it is equal to. So be mindful that these two are equal and they are the same. We will be dealing with a lot of complementary relationships. Now this is referring to our A value. We are going to have to find a complementary relationship with our B value. Now here our B is referring to our sine. So we will have saying sine theta is equal to B. Now if we are going across from this side, from pi over 2, that B value now is turning into our is adjacent, which is our cosine. So it'll be cosine pi over 2 is equal to our B value. So that is our second complementary. So when we're thinking about complementary relationships, it's like we're talking about a shift on a graph. So we know if I've got a sine graph here and a cosine graph here, they do not align. But if I have a shift over by pi over 2, then the cosine graph aligns with our sine graph. That's something we need to be thinking about. So now let's look at going into quadrant 1 and quadrant 2. So we talked about before that this area here is our B. So if we go, instead of saying pi over 2 um, minus theta, we're going to do pi over 2 plus theta. That is still going to be equal to A. So be mindful of that. And we know from here, our cosine theta is our A value right here. So we do have a few relationships to consider. So that means we know that sine pi over 2 plus theta is going to be equal to cosine theta. Likewise, there's going to be a relationship with our a's. So be mindful of that. So again, just make sure we're drawing a picture to visualize everything that will help us. Now, we know when we're dealing with our triangle, it's a right angled triangle, so we can deal with it in terms of our Pythagorean theorem, a squared plus b squared equals c squared. That's why I've got cosine squared for a, sine squared plus, so it's equal to 1 squared, which is 1. So that's why it's just 1 here. So that is our relationship that we go back to from learning in year 8, the Pythagorean theorem. We are going to now use our understanding and apply it. So we've got given sine x is equal to 0.4, cosine is equal to 0.6, and tangent is equal to 0.6. Find the values of cosine pi minus alpha. Okay, so first thing we are going to do is look at where we're focusing on. So on the unit circle, we're dealing with pi, and we're minusing alpha here. So that we know this here is 0.6. In this quadrant, we know cosine is negative, so it'll be negative 0.6. If I'm wanting to find the values of sine pi over 2 minus x, again, I go pi over 2 minus x. I'm dealing with this point right here. So that means I can use my understanding that it is in quadrant 1. Quadrant 1 for sine. Sine is positive. So first we are dealing with x, so we know sine x is equal to 0.4. So the second part, I'm going to use Pythagorean theorem, and the reason why is I know if I'm dealing with cosine A, it is going to be equivalent to sine pi over 2 minus x. So we need to know that complementary relationship. So that means I'm just going to put in my Pythagoras theorem and substitute 0.4 into sine. So that gives me cosine squared plus 0.4 squared equals 1. 0.4 squared is 0.16, and then I take that away and I get 0.84. I square root that on the calculator and I will get square root 21 over 5.